Hello everyone and welcome to my presentation. I'm Jerren. I work at M&T Bank where I'm a technical team lead overseeing process and test automation. I'm originally from Columbus, Ohio. I moved here with my dog and girlfriend about 6 months ago, where I left behind my glorious Scioto Valley Rugby Football Club. So like it sounds, I'm also into rugby pretty passionately. From a coding perspective, really good at Ruby Cucumber, test automation, also pretty good at Jenkins and general CI/CD processes. So that's a bit about me. What we're going to be talking about today is this, slaying the Leviathan containerized execution of test automation. So this is the great white whale from Moby Dick. This is a play on words with Docker having a whale as well. So we're going to talk about test automation in the context of Docker, and that test automation is Ruby Cucumber test automation. Components. What we're going to talk about today, we're going to talk about the background of why this became a presentation. There are a few blog posts that will provide some additional details on. The problem, what was I trying to solve when I built all of this functionality out? And the execution diagram will really talk about the solution to that problem at a high level. So define the problem, define the solution. We're then going to dive into the solution's components, mainly Collateral Cucumber and the Ruby Cucumber implementation. Collateral Cucumber being a gem and Ruby Cucumber implementation being a GitHub repo. And then I'm going to talk about some of the risks you may not think about when this is implemented. And then we're going to wrap up. So without further ado, let's get started. So this presentation I'm giving now has been in the works for about 2 years as a set of blog posts. Slaying the Hydra was the first one on the right there, and it has to deal with test automation but doesn't integrate Docker or containerization into that conversation. It's really just about parallel automation. And then Slaying the Leviathan, which is about parallel automation in the context of Docker. So these both are great for additional details and background on this post, but in general, I recommend going to redgreenrefactor.com. That's where I posted both of these. There are some other authors on that site, mainly Thomas Haver, Josh Russell, and Andy Griffin, that provide a great deal of meaningful information about test automation and just general CI/CD stuff. So that site is out there if you want to check it out. So we had a problem early on in my career. I saw this a lot actually, that we would have a single threaded test automation execution that validated functionally the regression, typically a web app or a mobile app and those sort of things. And the regression would be rather large, like 500 tests, and it would take a long time to run, 8, 9, 10 hours. 10 hours for 600 tests is a minute a test. So it's not like the tests are taking a long time for functional tests to run. It's just that we're not running them in parallel at all. So this feedback loop made our app developers, made our business, and our automation engineers less really interested in what was going on with the regression execution and its success. They would just kind of say, well, hey, as long as the regression's passing at X%, we're deploying code. But it wasn't a meaningful regression execution because people weren't looking at the failures real time and diagnosing them. And it's because it takes so long to figure out what the failures are. So, like any process, I work on an agile team. This is a huge bottleneck for those teams. So we worked to remove this bottleneck, which is in essence single-threaded execution. So how are we going to do that? All right. So one thing about Docker I will say before I dive into the slide, which is the diagram as to our solution, is Docker is a tool for running containers. And if you don't know what a container is, it's okay to think about it in this context as a VM without an OS. So a VM that has a lot less resource cost to set up and can be tore down dynamically and then spun back up from a set of specifications, which is actually the image. Docker image and Docker container are two different things. Image is you build containers out of, but an image is not a container. What else does Docker do? It's dynamic. So you can run varying numbers of containers completing similar or different tasks. The only limit with Docker is the host system as far as how many containers you can run. So the host system resources put a damper on you just infinitely expanding the number of containers. From a test automation perspective, Docker gives us parallel automated instances, dynamic containers in the sense that I can pass environment variables and parameterize those containers to do unique things for me. And Docker is open source. Not all of Docker, not Docker Enterprise Edition, but this version of Docker that I use for this presentation and the corresponding code base is the open source version. So if we look at this diagram, we can see that we're passing a certain number of parameters, total builds and build number. Total builds you can see is static and that it is 3 across all 3 containers, where build number is either 1, 2, or 3 based on container 1, 2, or 3. So what this allows me to do is signify what container I'm in and how many total containers there are, and that allows me to split the regression in a round robin sense based on n number of containers. So it will go through, figure out how many containers there are, and retag the scenarios. So in this sense, only a third of the scenarios would execute on every container. So now we've taken our regression that takes 3 hours to run and cut it down to 1 hour and 15 minutes or so. And that's all done in that Ruby process within the containers. That retags and then it executes the test. The last part of this diagram is what Jenkins does for us. We could look at Jenkins from a CI/CD perspective and say Jenkins could run everything for us, the same way GitLabs could, or Bamboo, or ADO. We could use this to schedule like the construction of the Docker containers and then tear them down and extract what we wanted to. But we can do that with any CI/CD tool. One thing that Jenkins has that is really nice is a Cucumber report consolidation plugin. And that plugin allows us to take all the HTML reports from all the Cucumber executions across the containers. So you had 3 containers, you're going to have 3 Cucumber reports, and consolidate them into one viewable report. All right, so this diagram is a 10,000 foot view. I do want to go a little deeper into the individual components of this diagram. So let's do that. Collateral Cucumber. This is the Ruby gem that I built. It provides the ability for the containerized instance of Cucumber to only run a certain set of tests. And it does this, like I said, by retagging the scenarios. And it's actually going through the feature files, finding all the scenarios, and then in a round robin manner, meaning every nth scenario gets dropped into a bucket. So if I had, let's say, 5 scenarios here, scenario 1 would end up in bucket 1. Scenario 2 would end up in bucket 2, scenario 3 would end up in bucket 3, and then it would go back to bucket 1 and bucket 2 and put a scenario in each of those. So this round robin, every nth scenario getting assigned to a different bucket, allows us to split up scenarios, and that benefits us because we don't have those chunks of long running regression scenarios that would otherwise hamper our ability to efficiently split up the regression. The other part of Collateral Cucumber that is really cool is that it allows us to tell it which set of tags we want to replace. So I can say I want to run the regression, which is signified in Cucumber as @regression. We can see there. If I signify that within Cucumber that I want to split @regression, and I have 3 builds, the first build would do what you see here on the right. It took contact us1 from @regression to @split builds. So what that means is we have now the ability to just run scenario 1. We don't need to run scenario 2. Scenario 2 would be ran on container 2. So that is what Collateral Cucumber is. The next part is going to be talking about the Docker Web Repo. And that's the implementation in GitHub that just shows a way you could utilize this. This framework that I built, it utilizes water, so it's a Docker Web Repo. You could just as easily utilize anything that utilizes Ruby Cucumber. So Appium, API automation, database automation. If you're representing it in Gherkin in Ruby Cucumber, you can split the execution with this gem. So like I said, this example is a web automation example, so we're going to talk in that context from here on out, and you can see the structure, which would be standard for anyone that's used to Ruby Cucumber. So we talked about Docker a little bit, but I want to dive deeper into what it's doing. What's actually happening here is we have 2 components to Docker that we're utilizing. One is a Docker file, and a Docker file is a set of specs to build an image. And images are static, but once an image is built, you're allowed to instantiate multiple containers from it. So if you think about an image as a set of instructions, the container then utilizes those set of instructions to build. So in this Docker file, we're very specific to including a Cucumber env from, which is another Docker image that I built that has the basic Cucumber environment set up. Once we get that set up, we're cloning this repo down, our repo on GitHub, because that's where our test automation scripts are, and that's what we need locally within each Docker container we run. We then install prerequisites like bundler and bundle install. That is the prerequisite installer. One of the last things we do is run cc runner. And cc runner is just running the Collateral Cucumber script, Collateral Cucumber gem, and that is splitting up the execution within the container. So it knows what build number it is, and it knows the total amount of builds. Therefore, it's able to say, I'm taking every 1 out of 3 scenarios, or every second scenario out of 3. The other component is a Docker Compose file. This is a set of instructions for running multiple containers in concert. So you can tell it environment variables you want to pass between containers, like we're passing total number of builds as 12 in this example, and then we elicit 12 services, and each one of those has a unique build number. So we're passing that build number and total number of builds into that container that is running a local instance of our Docker Web Repo. The other component of this I want to talk about is the Windows CMD file that you'll see at the root of the directory you pull down from GitHub. This does pretty much everything you need to do. It'll spin up the compose instance, it'll bring it down, and it then copies the logs out of the instance and the HTML output for Cucumber. So what this does is provide us the meaningful artifacts out of the container before the container is destroyed. The other component, which is much more specific, is the Collateral Cucumber runner. And that's much more specific because it actually just runs Collateral Cucumber and passes a few parameters to it. So you would see the CMD file kick off the Docker Compose file, build a bunch of containers based on that image we built in the Docker file. And then in each one of those containers, it's running an instance. It has an instance of the GitHub repo. And in that instance of the GitHub repo on each container, it's splitting the execution up by this Collateral Cucumber runner, which is running the Collateral Cucumber gem. It's just important to know that we're running in each container's context. So the Collateral Cucumber runner runs every time a container is spun up. The last component that we implemented is Jenkins. So obviously CI/CD execution. I use Jenkins, but you could use GitLabs, which is top left there. You could use Bamboo, which I wouldn't recommend. I don't hear it much. Jenkins, which is great. I have my certified Jenkins engineer certificate. I really appreciate what they do. And ADO, lastly but not least. All of these would work fine. The one thing that is unique about Jenkins is the Cucumber report plugin. And that plugin provides us the ability to look, because we're going to have multiple Cucumber HTML reports and JSON reports, at all those reports into one consolidated view. One of the last things I want to talk about, one of the longer slides that I really have, is about risk. So this solution seems great, and it is great in a lot of ways, but you will see a few things, if you have a similar experience to mine, that kind of shock you. And one of them would be flaky test. So there can be a lot of overlapping data dependencies in an automation suite as far as the test data that's being utilized across scenarios and features. And when you run single-threaded, you typically do not come across those issues because the data is only being utilized by one user profile or account at a time. When you start to have 20 or 30 scenarios running at the same time, that user could be logged in or activated in 5 of those scenarios at the same time. So having that similar data has put a risk out there that now our test scenarios cannot pass because the data utilized within them is not robust enough to handle parallel execution. So that's one risk. And how you can get around that is really a gold standard definition of generating your own test data at runtime. And that's a whole different talk. But that's how I would say get around that, is your data should not exist before your test runs. I know that's not always possible, but that's a gold standard for you. Strains on environment. One of the first times I implemented this sort of solution, we ran our regression a lot more than we typically did. We were running it about 4 times a day versus once a day because our execution had went from, I think that team was at 6 hours, and we cut it down to 45 minutes. One of the things you'll see though is once you run that execution a lot more, if you're in a lower environment like a dev or test, not like a cert or perf really, you could see that the environment itself is not able to handle those amount of transactions running through it. Expectations is another one. This is not a silver bullet. Stuff is still going to fail all over the place, and that's really why we have careers, is to fix it. So I do think that this solves a huge problem. I think it's better than a lot of other solutions I've seen out there, but it is not a silver bullet, and things are still going to break. All right. So in summary, shortening the feedback loop with automated validations in parallel dramatically helps the team because there's less context switching, and then there's more frequent deployments. I also think that this sort of stuff is fun because you get to integrate technologies together, like Ruby, Cucumber, Docker, so on and so forth, Jenkins, and then you get to see them do a thing in a linear sense. And I have multiple implementations of this under my belt. I've done it with Appium, I've done it with API, and I've done it with web. So if this is something that sparks your interest and you want to implement a version of it, I would recommend looking at the GitHub repo. And then if that's not enough for you and you need more help, just reach out to me. I'm more than willing to do that. And to go into reaching out, I would say this. Here's my contact info. That's my email address. I do look at it a lot, and that's my LinkedIn information. So if you want to reach out, it's there. The only other thing I would say is that M&T, the bank I work for, is hiring a lot of technologically apt people across a various grouping of fields. So if you are in the tech industry and you are looking, I'm not saying that they're going to have a position for you, but it will be worth looking at because they are bringing a lot of people in right now. Outside of that, I really appreciate everyone taking the time to listen to me, and I will be on the Discord channel replying to comments as I probably have been for this whole talk. So thank you, and have a good day.